Hey guys, thanks. So going back to chapter 2, we talked about what a function is. Okay, let's do this. Or on Thursday, we talked about what a function was and how you know what a function is. Tell your neighbor real quick how you know if a graph's a function.
You pass the vertical line test. It can't be two dots in the same.
All right. So usually when we're talking about graphs, if a graph passes a vertical line test, right? So if this was our graph, if we slide a vertical line across it and it passes that test, then it's a function. In other words, our vertical line doesn't touch more than one spot on that graph at a time. Okay? Huh? Well, kind of, like if you look here, yeah. So would this one be a function? No. Would that be a function?
Yes.
Yes. Would that be a function? Yes. Okay, it passes the vertical line test. So when we're dealing with functions, we need to understand what function notation is. Function notation, okay, function notation is when we have something in the form of f of x or something of x, maybe a of x or g of x or f of t. Anytime you have, it could be f of t, we see that a lot. Okay, f of t equals 5t plus 3 or something. That is function notation. F of whatever is here, and then that variable also appears over here. Now, they look pretty easy, and when we go through the explanation, they seem pretty easy, but what happens is students really get confused with this part of it sometimes. So I want to make sure we're clear on what that does here. This rule shows that f of x is a function of x. Another way to think of f of x is really the same thing as y. So when I say f of x equals 2x minus 5, I'm really also saying y equals 2x minus 5. Okay? They mean the same thing. All right, in terms of what we're doing here. So y equals 2x minus 5. All right, we read this as f of x. It has no mathematical operation in between the f and the x. It's not multiply or anything. It's just a different form of writing stuff. Yeah?
What's the point of having it if it's just within the norm?
Well, it allows us to put input values for x and get a quick output. Okay, it tells us that something's a function because it's in function notation. Okay, so you're going to see that on a bunch of what we do today. In fact, why don't you guys take the packet you grabbed on the way in, or the sheets you grabbed on the way in. Let's look at a few of those. Okay, some ones that I want you to try out in your notes. You can put the answers on the packet, but if we're doing these problems here, this is a function. It says f of x equals 5 times the absolute value of x minus 4, all minus 3. It says we're trying to evaluate each of these for the given input or output. Well, this says f of x equals 27. So there are two places that we can put this number. We can either put it in for x, or we can put it in for x or for f of x. Should we put the 27 in for f of x or for x? Tell your neighbor what you think.
F of x. F of x, because it says.
Oh. Okay. So should we put the 27 in for the f of x or for the x? Yeah, for the f of x. It says f of x equals 27. So what I'm going to do is I'm going to take this equation, or this function right here, f of x equals 27, or equals 5 times absolute value of x minus 4, all minus 3. And I'm going to plug that 27 in for the f of x value. It's going to go in right there. So now, rather than having f of x there, I am actually going to have the number 27. And anytime I substitute in math, I put parentheses. Sometimes it'll seem like that's a big waste of time, but there will be times when it saves you a lot of headaches for having to do the problem a few times because you messed up. Okay, so in this case, it seems like a waste of time to put the parentheses, but it's okay. All right. How do I solve an absolute value equation? Trevor? Yeah, we got to get the absolute value by itself. So everyone get the absolute value by itself first. First thing we did. Vincent? Good, add 3 to both sides to begin with. Okay, so bring that 3 over. Okay, you get 30. X minus 4 there. Okay, next step. Go ahead,
Divide
Danny.
both sides.
Oh,
Oh, okay. Never mind. Go ahead, Dean.
go ahead, Nathan.
Divide both sides by 5.
That's my fault. I shouldn't. I kind of point and call on people. That's a bad habit. So divide both sides by 5. So we get 6. Yeah, that wasn't too nice. All right. Danny, do you know what to do next?
Yes. Now you have to do x minus 4 equals 6 and x minus 4 equals negative 6.
Good, we've got to do a negative case and a positive case. Negative case is x minus 4 equals negative 6. Positive case is x minus 4 equals 6. These are the types of problems, by the way. There are 2 problems we struggled on the CBA we did in the last chapter test. The absolute value ones were those. So it's a good quick review of this. Add 4 to both sides. We get x is equal to negative 2. And add 4. We get x is equal to 10. So 10 and negative 2. Those are our solutions. Okay? And if we tested them out, see if they were right, we put the negative 2 in. Negative 2 minus 4 is negative 6. Negative 6 times 5, or negative 6, the absolute value of negative 6, which is 6, times 5 is 30, minus 3 is 27. We have that 27 in there. Okay? And then if we put the 10 in, the same thing would happen out. So I won't bore you with that, but you can always check them. All right? Declan, question?
No, never mind.
Okay, note the difference between that problem, where it says f of x equals 27, and this one, where it says x equals 2. Tell your neighbor how you're going to solve this one. What are you going to do differently?
Put for n.
Here to tell me what I do differently. Josh?
You don't plug in the 2 for f of x, you plug in for x.
Good, you plug in 2 for x rather than f of x. So if I take that same equation, f of x equals 5 times the absolute value of x minus 4, all minus 3, the 2 is now going in for x. It drops in right there. So now I have, and also drops in right there. Wherever you see x, you plug that 2 in. So now I have f of 2 equals 5 times the absolute value of 2 minus 4 minus 3. So now here's where students really get confused. Okay? I have students going, what do I do with this? I have students trying all kinds of goofy things. I want you to try to solve that one. Make sure you're using pencil. And it's okay to make mistakes. I want you to get all the mistakes out right now on this problem. I'm not going to answer questions on how to do it. Do you know?
Pencil I can use?
Yeah, I'll get a pencil for you.
Who is it for me?
All right, here we go. So this is where students get confused because they're like, there's no variable anymore. And they see the f and they're like, okay, so I usually move things away, so maybe I try to add 3 and then divide by 5. Did anyone try that?
Yeah.
Okay, that's a mistake. That's okay. You made it. Notice on this, there are 2 separate sides of the equation. So I need you completely focused right now. Otherwise, this becomes a headache for the rest of the time dealing with absolute values and functions. Okay, there are 2 separate sides. This side over here has the f of 2, and then this side has a bunch of numbers. When there aren't any variables, just do the math. Right? There's not a variable on this side. Just simplify. So you look at the absolute value. You do not distribute the 5 into absolute values. You just do what's 2 minus 4.
-2.
Negative 2. Times 5 minus 3. Okay? One step at a time. We just keep simplifying. Here, what's the absolute value of negative 2? 2 times 5. Now notice there's implied multiplication there. Okay? Minus 3. Yes?
The rule is that you have to do to one side what you do to the other, though.
No, I'm simplifying. I'm not doing inverse operations. It's okay to just simplify a side. So right now, all we're doing is the math here. When it says minus 4, we're just doing that because it says minus 4. So what's 5 times 2? 10. Minus 3 is 7. So now what we have is all of that. We've simplified that entire side. That whole thing equals what?
F is 2.
That's what f of 2 equals. So we do not divide by 2 now, though. Okay? So this just says f of 2 equals 7. If it's easier for you to think of it this way, you could think of f of 2 as being the same thing as the letter y. You can think of it as y equals 7. These two things essentially mean the same thing. Once we know that the input was 2, the output is 7. The whole point of doing this is so that we can get an ordered pair. So by writing this out, that's okay to do. It's okay to say that rather than calling it f of 2, you can call it y. If that helps you way up here, to just start going, okay, put the 2 in, so now rather than doing that because that confuses me, I'm just going to write it as y now the rest of the time. That's okay with me.
Will it affect us in college?
Will it affect you in college?
No, like high school and stuff.
Hey, well, the reality is in math, eventually, the further you go in math, you'll be okay with function notation, so you won't have to replace it. It won't affect you unless you get an over anxious. It's not going to affect you in the next 4 or so years, unless you get a teacher that's a little anxious about it and they make you leave it. But by then, you're going to be fine with it. Okay, I would guess by the end of the chapter, you're going to be fine with it. But for now, if it helps you to write it as y, then go ahead. Really, what you've done here is you have an input of 2. You're saying when x is 2, what's y? 7. That's what we've done, is we've come up with a input-output, or what we like to call an ordered pair.
We have to graph these somehow.
Which tomorrow means we're going to start graphing them. So really, the whole point of doing this is so that we could use that to plot points. And if we put in enough values, we'd have enough points to plot to draw a line for it.
Wait,
I'm waiting.
so letter A. When it says
It's not very
-2,
nice.
10, that's a coordinate?
That's a coordinate.
That's mind equals blown, guys.
Mind equals blown. All right, very good. Everyone try letter C and D on your own, please. Letter C and D. Give them a go. I'll be walking around helping out, but I want to make sure we're good. This front page, I think, is the toughest of all of them. So try C and D. Okay, I'm going to set one up here and see the work on it. That's Ryland's letter C. Okay? All right. Hey, so Ryland added 3. Very good. So we plugged the 12 in for the f of x, so 12 equals, so rather than having f of x equals, we're going to have now 12 equals 5 times x minus 4 minus 3. Okay, plug the 12 in. We add 3 to both sides. Good. Divide by 5. We get it down to the absolute value being alone. Positive case, so with the 3 being positive, so x minus 4 is equal to 3, and x minus 4 is equal to negative 3. Add 4 to both sides. Nice work, Ryland. Well done. How many got 1 and 7 there? Very good job. All right.
Oh, does it matter what order it's in?
7 and 1, 1 and 7. It's okay.
Wait, but then, question.
Yeah.
Okay, so when you're putting it on the graph, how do you know whether to go 1, 7, or 7, 1?
These are both x equals, right? So really you have, Ryland, you mind if I write on here?
No.
Really you have 2 coordinates. You have when x is 1, y is 27, or as y is 12, excuse me. And when x is 7, y is also 12.
So they're not the right coordinates.
No, those are the correct coordinates. It's just when you see an absolute value graph, we'll see this later on. An absolute value graph actually looks like this. It's a V shape. Yeah, it's very cool. Very. Yeah.
That's funny.
Very, dude.
Oh.
Come on, man.
Woo, that was
Oh.
a good one.
All right.
I think it's slapped.
Hey, the next one Ryland's got here, he's plugged in -3 this time for the x. So he dumped it in right there. He did -3 minus 4. I think. I'm not sure what happened here. Oh, did you distribute? So did you just drop the absolute value symbols?
Yeah.
Okay. So we don't want to do that. Okay. We'd actually, let's go from here. I'm gonna write it up here. In fact, let me give Ryland here. Will you pass that back to Ryland, please? Just kind of, Abby will take it. Thank you, Ryland. Good job, though. We got f of x equaling 5 times x minus 4, all minus 3. So check out what we did. We plugged that piece in there, which Ryland had perfect. So he puts it in there. He puts it in there. Okay, 5 times -3 minus 4 minus 3. So that's what f of -3 is. Okay.
Question. What if you forget to put the -3 in the
Like over here?
Yeah.
It doesn't matter. We're going to ignore this side anyway, right?
Yeah.
So in fact, I'm just going to set my pencil on that side. There. All right. And so now we have 5 times -3 minus 4 is -7, all minus 3. Absolute value of -7 is 7. So 5 times 7 minus 3 is just 35 minus 3, or 32. Okay? So we just keep bringing that down, simplifying that side. So f of -3 equals 32. Or if you wanted to, you could have called it y, right? If you just wanted to say that's the same thing as y equals 32. So you order pair, what would x be? And what's y? 32. All right. Nice work. Okay, that's our solution. How many got this one right? Okay, if you didn't get it right, you know where you made your mistake?
I just didn't do it.
Dude, you don't know where you're going to make mistakes. That's why we're trying. Any questions? Ricardo? Oh, the infamous, are we going to have to do the whole packet question?
Well, there's only 9 problems.
I'm going to let you skip 6 problems, but I'll tell you which 6. Okay, 6, I mean, I'm not 6 to, I mean like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, you know, when I'm counting down the front page. We've done 3 of them, or 4 of them together. I'm going to let you skip 6 more, but we're going to do a few more together right now. So I want you to turn the page and look at the second page. Page 2. It says evaluate each linear function for the given input-outputs. I want you to take a look at A and B. Try to do both of those, please. Given a different type of equation this time, it's linear. Okay, meaning no absolute value symbols. And x is to the first power, which helps us out tons. All right, here we go. So Abby has volunteered her paper for us to take a look at and say, amazing work, Abby, or not so amazing work. This is what we'd do different. So she's put in 20 for f of x. So now we have 20 equals 2x plus 10. Well done. Subtract 10 from both sides. Divide by 2. X equals 5. How many got that one? Yeah, man. So and you can check it, right? 20 equals 2 times 5 plus 10. That's 10 plus 10 equals 20. We're good. Any questions on that? Kylie, did you do it? Did you get it? Were you taking a look at those cool tessellations? Oh, at the rocket?
No.
It's not a real rocket. It's like one they built in science.
It is
No.
not.
Yeah? I don't know. The lights? The lights are mesmerizing. Oh. The ones up in the ceiling.
Oh wow, those are so nice.
They're pretty good.
Are we gonna make them?
Okay. The lights? No, they've already made them. They light up our room.
I mean the rocket.
No. That's for science.
Is it challenge
Isn't this
size?
science?
I don't know.
No, it's regular size.
For some people, it's challenging. Okay, letter B. So Abby's, let me get you going back up here. I'm sorry that Kylie distracted us like that. Okay, we put 6 in for x. So we have 2 times 6, which is 12 plus 10, or 22. So f of 6 equals 22. How many got that? That is correctamundo. Okay, remember, we're not doing anything with the f of 6. F of 6 is the same thing as saying y equals 22. Okay, Kara, you got a question?
Yeah, how come on for A,
Oh.
we didn't take, because on A, I messed up, because for the X, I put 20 in the parentheses. How come we wouldn't do it there, but we do it in B?
It's a good question. Notice the different notations. This one says f of x equals 20. So we're putting that piece in for the f of x. The 20 goes directly for that thing. This one says x equals 6, so the 6 goes in directly for the x this time. Okay? Good question. Abby, I'm sorry I wrote on your paper. All right. Any other questions? Okay, why don't you turn the page, please? Let's look at the next page. Quadratics. They're totally quadratical. Okay?
Was that a last one?
We are going to skip 6 problems on this page. Okay, we are going to skip number A and number C and letter A and then letter C and letter A and number C. Yes. So if I've confused you with A's and C's, let me zoom out. You're skipping A's and C's.
Why?
Because you'd have to know how to do quite a few. You'd have to know how to factor to solve, or use quadratic formula. Okay. All right. So what I want to do is B and D together. That be D cool. Okay. So I need everyone to try B to begin with, and then pause. If you want to go back and work on previous pages, you can after you do B, but try it and then pause. I'm supposed to be taking roll every period. I didn't do that today. If I forget to call out your names, please remind me. I keep forgetting. Emails from the office. Andrus.
What?
Did I say that right? If I
Maybe.
say your last name wrong, let me know. Anderson.
Here.
All right. Askable.
Here.
Behe. Okay, say here. Sorry, I thought maybe that would be clear. Behe. All right. Benjamin. Here. Bennett. Carter. Here. Cortez. Here. Davis.
Here.
Graham. Hemmingson.
Aquí. It means here in Spanish.
Oh. Okay.
Doesn't know Spanish.
That means okay in English. Lewis. Mays.
Here. Here.
Oh, McBride. No Jared. Magruder. Here. Noha.
Here.
Mesky. Marino. Man. O'Toole.
Here.
Radaba. Is it Radaba? Ray? Rattery. Rinaldi. Sammy.
Here.
Uter.
Here.
Is it Uter? Got it.
Yeah.
Which one? Can't be both. Uter? Okay. Whitman. Weiser. Yes. All right. A couple of you's gone. Crazy, man. That's where you live when you're camping.
Mr. McCoy, Ashley says that you pronounced your last name wrong.
I said my last name wrong?
No.
Askable?
Yeah, it's like an O. The A is like an O.
It's
Ask Old?
No.
It's Oscable.
Oskable?
Yeah.
I've always called it Askable. Is it Oskable?
Everybody does.
Because her dad got a red card in soccer, and he
Everybody said.
that
Is it Oskable, really?
and then so her grandma changed it. She got a red card in soccer.
All right. Well, hey, now that we, I think we need your attention back up here. I think we recorded roll. So that's okay. I forgot to pause. Hey, when you're putting this in here, we have our 6x squared minus 2x plus 4. You're putting your negative 2 in for x. So there, and there. All three places, right?
Oh, I forgot that part.
This becomes f of negative 2, which we know we're going to ignore. 6 times negative 2 squared. This is when the parentheses really mean something big. So when you put those negatives in, that parenthesis means a big deal. Otherwise, it looks like 6 minus 2. Stay focused, please. This is the last problem we'll do. Okay? We probably won't do D together. So, from here, this negative 2 squared is what we do first. Now, did anyone actually multiply 6 by negative 2 before they squared it? Willing to admit it? Okay, some people do that. Some of my trig students still do that. Okay, it's negative 2 times negative 2. That's what negative 2 squared means. So that's 4. Negative times negative is positive. So now I have 4 times 6. Okay, that part became that minus 2 times negative 2 plus 4. So I'm just simplifying that side. I'm kind of ignoring this other side, right? 6 times 4 is 24. Negative 2 times negative 2 is 4, and it's a positive 4. And 4. 24 plus 4 is 32. So f of negative 2, or if you wanted to call it y, after you plugged in, y equals 32, or you could think of it as f of negative 2 equals 32. However, it's more helpful for you to think of it. Trevor.
How would you get a positive if it's like negative, like the exponent and the exponent's a positive?
So right here,
Yeah.
negative times negative
Oh,
is positive. Good question. Other questions? What's that?
How's that a negative times a negative?
This negative 2. Negative 2 squared means negative 2 times negative 2.
Oh, got it.
That's what negative 2 squared is. So if you did this on your calculator, you guys, if you just threw this into your calculator and you didn't put parentheses around that and you hit squared, it's going to give you a negative 4. So if you actually typed into your calculator negative 2 squared, it'll give you negative 4 because it's saying 2 squared times negative 1. And that's when students usually go, my calculator's broken. I'm like, no, you just didn't program it right, dude. You got to put parentheses around it.
wait, how do you do negatives in your calculator then?
You use the little negative symbol at the bottom of the key.
No, but when I do that, it always says it's
Error.
error.
Oh, you sure you're not using the minus symbol instead of the negative symbol?
Oh, I am using it. Oh, I found it.
Yeah, it was hiding. All right. You guys have your assignment. Let me know if I can help out. I'll be walking around. The answers are on the board.